Okay, I want you to open your ISN and turn to page 49 and 50, and I want you to tape this down on page 50. This is, obviously this is not the real name of it, but it's called the side splitting theorem. You've seen this picture a lot in some of the similar triangles problems we've done, where you have a small triangle here and then a big triangle here. And the way we did it before was that the small side of the left side of the small triangle compares to the left side of the big triangle. The right side of the small triangle compares to the whole right side of the big triangle. But there's actually a shortcut, and some of you figured this out already, but if you have two sides like this that are parallel, it actually splits the sides of this triangle, where instead of having to figure out the whole thing, you can have just part of it. So A over B, these parts, equals C over D. So what we're learning today is not just about similar triangles, but all the different ways that you can have proportional parts, whether it's in a triangle or not. So if I have two parallel lines with a triangle, then you can have two different kinds of proportions. The first one right here is that A over B equals C over D. So top over bottom equals top over bottom. The other proportion is this one here. A over C, left over right, equals B over D, left over right. So from here, to solve it, you would just cross multiply and go from there. This is what we've done before, where you have the two similar triangles. You have the small triangle and then the whole side of the big triangle. So this is the part that we've done already. This is the new part that's also true, and some of you will like this better. You can still use this way if you like just doing the whole side, but this is the part you guys already know. Okay, I want you to add some notes to this, because the reason that this works, this side splitting theorem, is not just because they are triangles, but because these lines are parallel. So this concept of proportional parts actually is true for all different kinds of parallel lines. So let me show you what I'm talking about. Put a star right here and write also true for parallel lines that aren't in triangles. Also true for parallel lines that aren't in triangles. So I want you to draw this picture. Draw 3 vertical parallel lines. Okay, we're going to put little arrows on them so that we know they're parallel. And then I want you to draw one line going across this way and another line going across this way. And you can hit pause if you need more time to draw the picture. In this section here, I want you to write 10. This is 20. Down here at the bottom, make this X and this 30. So even though we don't have triangles in this picture, we still have proportional parts. Because these lines are parallel, it cuts these two lines here, the two horizontal lines. It cuts them into proportional parts. So we're able to make proportions out of this. You could do 10 over X equals 20 over 30. You could do 10 over 20 equals X over 30, as long as you do apples to apples and oranges to oranges. So I'm going to do 10 over X equals 20 over 30. And then if you're trying to solve for X, you would cross multiply. So 10 times 30, 300, equals 20 times X, 20X. Then you divide both sides by 20, and you get that X is 15. Okay? So the concept here is that when you have parallel lines, whether it's in a triangle or it's not in a triangle, you'll have these proportional parts that you just set up the corresponding sides or the corresponding pieces, and you write a proportion and you're able to solve. Okay? Now there's a second part to this lesson besides the proportional parts, and that deals with angle bisectors. So you have this taped on page 50 in your ISN. Just flip it over, and we're going to write some notes underneath it on the notebook paper in your ISN. So this is called angle bisector proportion. And I want you to draw a triangle and call it ABD. And I want you to draw segment AC so that angle BAD is bisected. So we're going to draw segment AC so that BAD is bisected. So remember, if it's bisected, that means this angle is the same as that angle. Okay? And here's what happens as far as proportions go. If angle BAD is bisected by segment AC, then the following proportion is true. I always like to use highlighters to show this, but if you're looking, you've got your two angles right here that are congruent, and you have your two top pieces and you have your two bottom pieces. So if the angle is bisected, it actually splits the triangle into two sets of proportional parts. You have your top two pieces that go with the top angle, and you have your bottom two pieces that kind of go with the bottom angle. So if we're going to write this out with letters, we can say that BC over AB. Now pay attention to how I'm writing this. I started with BC here and put it over AB. So if I'm going to match it up with this blue section, if I started with the bottom piece that's attached to C, what other piece do I need to start with now? If I said BC over AB, if I'm going to match that up in the same pattern, I need to start with CD over AD. I can't put AD on top here. I've got to match the same pattern. So I'm going to put CD over AD. So this piece over that one is equal to this piece over that one. So here's what that looks like in an example. Draw this triangle and show that this angle is bisected. So put the two angles showing that it's the same. Make this piece be 30. Down here is 12. X is this section, and then up here is 20. So you'll be given a picture like this and asked to solve for X. So I'm going to use my highlighters to kind of help color code things. So with this angle, it divides my triangle into these two pieces, and the other angle divides my triangle into those two pieces. So when I'm setting up my proportion, I can say 12 over 30. So I'm doing 12 over 30, and if I'm matching up the same pattern, I did bottom to this side, I'm going to do the other bottom section. 12 over 30 equals X over 20. Okay, so now when I solve this, I'm just going to cross multiply. 30 times X is 30X. 12 times 20 is 240. And from here, I'm going to solve. So divide by 30. So X is 8. Okay, so that's the two things you've got, and this whole section is called proportional parts. Okay, so you've got proportional parts. When lines are parallel, it gives you proportional parts, whether it's in a triangle or not. And if you have an angle that has been bisected, that also gives you proportional parts. So this is the second part of similarity that doesn't really have to do with triangles. Okay, now you should have this paper using proportions in geometry. I want you to go through and solve some of these to kind of get you used to finding these proportional parts. You can do all of them if you want to, but I at least want you to do number 1, 2, 3, 7, and then on the back, I want you to do 9, 10, 12, and 14. So go through and try those. The answer key is in my ISN, so you can get up and check your answers when you're done. But work together if you need to. Try setting up those proportions and solving for x.